All right, everyone, let's go ahead and do this. So today we're going to be solving exponential equations. All right, so look at these two examples here. They're both exponential equations. And we're going to solve these by taking the log because the log is the inverse of an exponential. All right, so let's look at example one. So if you have an e, which is a base e to the x power is equal to 72. So the opposite of a base e is a log base e, or let's say the inverse of a base e, right? Of an exponential with a base e is a log base e. So if we want to get rid of this base e, we have to do an exponential base e, right? So since this is a base e, we're going to go ahead and do both side log base e, both side. Notice that this log base e has a little e. Okay, it still has an e to the x, that's part of the equation. And it still has a 72, that's part of the equation, but I'm doing log base e both sides. And you know log base e is really ln. Okay? So ln of e to the x is equal to ln of 72. Right? By doing that, this ln and the e, or you can say this, so the ln and the e cancels out. Okay? Just like saying log base e of e cancels out. And that leaves you with just the x. So x is equal to ln of 72. And you can use your calculator because ln is a calculator log. So x would equal, and I'm going to pull out my calculator. Okay, not on the screen, but you have to pull it up on the side. So all you have to do is type in ln 72, and that gets you the answer of approximately, or let's make this approximately 4.276. Okay, let's look at the second one. Right, so again, these are exponentials, but before we do exponential, we need to make sure that it's only the exponential, okay, not the other stuff. So we need to get rid of that 3. So first we're going to go ahead and divide it by 3. Okay, now we have 2 to the power of x is equal to, and 42 divided by 3, 14. Okay, now we are where we need to be. Now we have an exponential base 2. So to get rid of an exponential base 2, we have to do a log base 2 both sides. So log base 2 of 2 to the x. Remember, this is one of our properties. And the property says that if you have log base a of a, right, that a and a, log base a and a just cancels out and you just get 1 left over, right, if that's your power. Well, same thing here. We have log base 2 of 2, which means that these will just cancel inverse out, and we will have x. So x is equal to log base 2 of 14. And unfortunately, you don't have this on your calculator. Your calculator don't have a log base 2. So you have to use a change of base. And that says that you do a calculator log of base e or base 10. I'm just going to use base 10. So you're going to use log base 10 of the big number 14 divided by log base 10 of the big number 2. Right? You can use base e or base 10. In this case, I'm going to use base 10. Right? If I don't write anything, it automatically means base 10. But if you want, you can also put a little 10 here, just to show that you have base 10. Okay, so on my calculator, you can check your work, see if it matches mine. But you have log base 10 of 14 divided by log base 10 of 2. That comes out to be, and this is approximately 3.807. All right. All right, watch the steps again if you need it. Okay, we'll do one more. Okay, this one's a little bit more advanced. So again, we have an exponential equation. Exponential equation is an equation that has powers. Okay, this is the exponent. That's why it's called an exponential equation. right? But the exponential equation has a base, and the base is the e. Okay, now I need to get rid of everything else besides that exponential, which is the e to the 2x. So I need to get rid of that -3, and I need to get rid of that 4. Okay, so let's do that. So first, we need to get rid of that -3 by adding 3. That's going to cancel. We will have 4e to the 2x equals 5. Just 2 plus 3 is 5. And now we're going to go ahead and divide both sides by 4. That's going to cancel. And now we have our exponential e to the 2x power equals 5 divided by 4. You can call it 1.25 if you want to make it easier for yourself. I like fractions. Okay, some of you guys may like decimals. So you can write it like this, or you can write it as 1.25. Huh? Either way is fine. Okay. Now, look at this. We have an exponential base e, so which means we're going to have to do a log base e, both sides. And log base e of e to the 2x and log base e of 5/4, or you could do it log base e of 1.25. Either way is fine. Okay, I'm only going to work with a fraction, but you can see how it's going to work out with the decimal. Okay, and again, this will cancel, and you'll be left with 2x equals, and log base e, you know it's going to be ln of 5/4. Okay, and then to wrap this up, we just need to divide it by 2. And we finally get x equals. Now, all of this, we got to put it into our calculator. Okay, check your calculator, see if you do it correctly, but you can do ln 5 divided by 4, or 1.25. Close that parentheses, hit equals if you're not sure, and then hit divided by 2. Okay, and that should get you 0.111. There's other numbers like 57, 17757. Okay, but I'm going to go ahead and stick with